So let's look at the following example in which we're going to use Archimedes Principle to help us solve it. Let's suppose we want to calculate the volume of helium needed if a balloon in which the helium is found is to raise an object with a mass of 200 kilograms. So we assume that the density of helium is 0.18 kilograms per meter cubed, while the density of air is 1.29 kilograms per meter cubed. So we also assume that our system of objects is in dynamic equilibrium. So that basically means that even though the two objects are traveling upward with a certain velocity, they're not accelerating, and that means that the net sum, or the sum of all the forces acting on the object along any axis, along any direction, is 0. So let's begin by examining our diagram, and let's find all the forces acting on our objects. So we have the helium balloon. Inside that balloon we have a ton of helium molecules. Outside of the balloon we have air molecules. And these air molecules, because there is a difference in pressure between the top and the bottom of our balloon, that pressure due to the air molecules lifts our balloon, and that force is known as the force of buoyancy, or the buoyant force created by the air molecules acting on our balloon system. Now, at the same time, we have two gravitational forces acting on our two objects. So we have the gravitational force that's acting on the mass, as well as the gravitational force that's acting on the mass of our balloon. So we not only have the mass of the object, we also have to take into consideration the mass of the actual balloon, the mass of the empty balloon. Now, earlier we said that our object is in dynamic equilibrium, and that means if we sum up all these forces acting along the same axis, well, that sum should give us 0. And that's exactly what we write in the following equation. The sum, or the net force acting along the y-axis, is equal to 0, which is also equal to, well, we choose upward to be positive and downward to be negative. So we have the force buoyancy, or the buoyant force, minus the gravitational force acting on the balloon, on the mass of the balloon, minus the gravitational force acting on our mass of 200 kilograms. Now, let's rearrange this equation and solve for the force mass, the gravitational force acting on our mass. So we get the following result. The force mass is equal to the force buoyant minus the force acting on the mass of the balloon. Now, what exactly is the mass of our object that is hanging from our balloon? Well, it's 200 kilograms, and let's represent that with the letter m. So m times g is equal to, what's the buoyancy force? Well, the buoyant force is simply the mass of the air that is displaced by the balloon multiplied by g, our gravitational constant. What about the force acting on the actual balloon? Well, it's simply the mass of that balloon minus g, our gravitational constant. Now notice that the mass of the air displaced by our balloon is simply equal to the density of the air multiplied by the volume of the balloon. And this is known as Archimedes Principle. So we apply Archimedes Principle to solve this problem. So multiply this quantity by g and subtract. The mass of helium is simply the density of helium multiplied by the volume of our balloon multiplied by g. Notice the g's appear on each term, so we cross out the g's, and we have mass is equal to, and the volume appears on both of these terms on the right side of the equation. So we can take the volume out. We get mass is equal to volume times the difference between the density of air and the density of helium. And since we want to calculate the volume of this balloon, the volume of helium needed, we simply solve for volume, and the volume is equal to the mass of our load, this mass divided by the difference in the densities of the air and the helium. So mass is 200 kilograms, divide that by 1.29 minus 0.18. Notice the kilograms cancel, and the M3s, the meter cubed, goes on top. And we get a value of 180 meters cubed. So, in order for our helium-filled balloon to raise an object that has a mass of 200 kilograms with a zero acceleration but a constant velocity, the volume of that balloon has to be 180 meters cubed.